Hi everybody, it's Jakub and I will show you how to solve the second example from this problem set. An athlete Jill has 3 medals. She won 3 medals. She must be very good. 2 of them have different weight from the third one, but she forgot which one that was and whether it was heavier or lighter. She has old balance scales and she can use them to weigh the medals. Show that she needs 2 weighings to determine which medal has a different weight and if it's heavier or lighter. Okay, so we will start from putting some medals on the table. We have 1, 2, 3 medals. You can see that I already made one black, to sort of between me and you, we know that that one is the different one. We still don't know if it's heavier or lighter, but it looks like it's heavier. Maybe it is. We also have all balance scales. They are featured in every single problem in this problem set, maybe except one, right? The one difficult problem at the end doesn't have it. But from the first example, we already know that it does not make sense to put different numbers on medals on either scale, right? It doesn't seem like we have a lot of different options here, because even if we decided to put different numbers of medals, it can only be like 2 versus 1, because like putting no medals on either side doesn't make sense, and we only have 3 medals. If you put 2 medals on one side, 1 medal on the other side, 2 medals are going to be heavier most of the time, unless this third medal is super heavy, actually heavier than the other 2 combined. But that would be very lucky on our side. We don't want to base this algorithm, this solution, on luck. We want to have a foolproof solution that works every single time, and we want to be able to show that in 2 weighings we can always do it, right? So we put 1 medal on either scale, right? Let's put them there, right? They are here now. And now what can happen is either if one of them is heavier, if this one's heavier, then this scale goes down. If this one's heavier, this scale goes down, right? If they are the same weight, they will balance. They will be in the same, and they will be in the same height, right? This is exactly what was happening in the previous problem. The scales can balance or not, right? Let's think first. What do we learn if they balance, right? If they balance, that means the 2 medals that we placed have the same weight, right? They have the same weight, and we know that among the 3 medals that Jill has won, 2 of them have the same weight, and the third one has different weight. That means that if the 2 that we put on the scales initially have the same weight, then the third one must be the odd one, right? The only thing left to do is to put that third one on the scales, actually number 1, put it on the scales, right? And then just measure it against the other 2, right? Against one of the other 2, because we know that the other 2, they have the same weight. So by putting the second, the medal we already know is odd, together with one medal we already know is the same as the other one, we learn if the odd medal is heavier or lighter, right? Obviously, without measuring it, without putting it on the scales at any point, we cannot find out if it is heavier or lighter. We need to put it on the scales at some point, right? We cannot leave it out. In the example 1, we had some cupcakes, I think, that it was possible that the odd cupcake was the cupcake that wasn't put on scales at any point. Here it's not possible. If you want to learn if it's heavier or lighter, we need to place it, we need to weigh it at some point. But that's the easier possibility. It's the easier case, right? If they balance out, we know immediately that the third one is odd, so we just put it, we just measure it, and we are done, right? What about if initially one of the scales goes down? If initially one of those scales goes down, the first measurement, you pick the first 2, you put them on, and we notice that this one is for example heavier, or this one's lighter. We don't know which one's odd, right? It depends on the third medal, right? If the third medal has the same weight as this one that went down, that means that this one is actually odd, right? If the third medal, on the other hand, has the same weight as this one that went up, that means that this one is odd. So we have to somehow compare. We have to somehow compare the one that we left out with one of those 2, right? So we just pick on random one of those, and we measure the third medal that we didn't measure before against one of those 2, and all 3 things can actually happen. New medal goes down. Like if the new medal goes down, the one that we didn't that we didn't pick, you know, that means that the other metal that we already measured and we are measuring again is the odd one and it's lighter, right? If the new metal goes up, that means that the other metal that we have already measured and we are measuring again is odd and it's a heavier one, right? Why? Because the new metal gets measured against one of the ones that were measured in the first step. And we know that one of the ones measured in the first step is odd. We just don't know which one. So we know for sure that the new metal that we are putting on the scales cannot be the odd one. It must be the regular one. It must be one of two that weigh the same, right? So if we have imbalance again, that means that the odd one is the one that we measured twice, right? So these two cases, A and B, are actually in some sense the same case, right? It's just sort of up, down, but it's the same thing. If they balance now, that means that the metals that we have on the scales weigh the same, right? So the odd one is the one that we now put away, right? We measured it in the first step, but in the second step we didn't measure it, right? And to find out if it's lighter or heavier, we just need to remember what we did in the first, what happened in the first step. If in this first step this third metal was heavier, then it's heavier. If it was lighter, then it's lighter, right? It might seem complicated. There is sort of like a decision tree involved here. We need to keep track of what's happening in each stage. If you feel lost, you're welcome to watch this video again. But basically, whatever we do require 2 steps to do this, because in the first step we always put 2 metals on scales, right? We cannot put 3 metals because that would mean the scales are always imbalanced. I mean, it can be imbalanced. And we can never find out all the information about the odd metal, because if you happen not to put it on scales, because we're choosing at random the first step, if you happen not to put it on the scales, then we can never learn if it's heavier or lighter, right? So we always require at least 2 steps, and in 2 steps you can always find it. It depends on what's happening. It's not as straightforward, but you can always find it in 2 steps as we have shown. Okay, I hope that has helped you to understand how weighing things work, and see you in the next one.